Hi everyone and welcome to the Plum Pot channel. My name is Kerry and today I thought I would make a quick video just telling you about some tips that I learned about recently about optimizing your CAD design specifically for when you want to 3D print it. Okay, so this is the story. I needed to create or draw and print a box to house my very messy electronic components and development boards of a project that I'm busy working on. I just wanted to gather it all together in a neat way that I can work with. So I hopped onto Fusion 360 and drew a box and imported some components and put it all in. I was really quite proud of myself actually. And when I exported it and put it into my 3D printer slicer software, I saw it was going to take about over 11 hours. So I thought, well, let me just check the internet to see if I can find some good tips and optimizations that I can do to the drawing to give it the best chance that it will be a really good print. So I Googled it and I couldn't really find that much information. Particularly for beginners like me, we just want to know a few things. So luckily though, I have a friend who is a super genius in the 3D printing and he's very knowledgeable, and he very kindly agreed to review my design for me, and he came back with a few tips and pointers for just make little modifications to my design to make sure it came out in the best, well, that the print was the best result it can be. Guys, these tips were super useful and valuable to me, and so I highly recommend that you go check out Linton's social media pages. He's just starting up his social media presence, and I really encourage you to go give his LinkedIn page a follow, and he will be starting a YouTube channel soon, he said, so keep an eye out for that as well. He also has a website, and don't worry, I'll put all of his details in the description of this video. Just a quick note before we get into it, these tips were tips given and recommendations given on this particular design. So I'm sure there's way more tips for optimizing your drawings for 3D printing, but this is just a short list just relating to this particular design. But I'm pretty sure that some of these can be taken across to any design. So this is the drawing that I drew originally. Now, I don't think it's too bad for a first time attempt. So basically I needed a box just to house my development boards and messy wires and things of this project that I'm working on, as well as nicely mounting a motor on the top and stuff like that. So it's just a simple box with a lid, screw-on lid. Has a few holes on the sides for power jack, power switch, another hole on the other side just for some more wires to come out the side. Yeah, so I just used some spacers to mount the PCBs, so there are holes on the outsides. And yeah, this is what I sent to Linton at Richie 3D for a review. So this is the drawing of the box that he sent back to me after he implemented some of his improvements. But let's dive into them one by one. So now let's have a look at the tips and tricks that Linton gave me. Just another quick note, these tips are in no particular order, just a random list. Okay, so the first tip is wall thicknesses. So my original thinking was to go with a wall thickness that was a multiple of my nozzle size, so 0.4 millimeters. So I went with a wall thickness of 1.6 millimeters, and I thought that would be okay. And I think it might have been, but Linton suggested that we work in wall thicknesses of 0.8 millimeters. And since this wall is quite tall, it's 10 centimeters tall, and there's some holes in it, and there's some extra things to be mounted on it on the side and screwed in, he recommended that we make it a tad thicker, so we made it 2.4 millimeters. And I think that was a good call when I see the finished print, that the walls are really sturdy, and you know, it's a very sturdy box in the end, and it worked out really well. So yeah, I think if you're going to have things hanging off the edges, then and some holes that you need to mount some other things into, then perhaps thickening up the walls is a good idea. The next tip is regarding these standoffs. So although the screw-in metal standoffs would suffice to attach the PCBs to the inside wall of the box, it would mean that there would be holes on the outside of the box. So Linton showed me a technique called integral support, which she demonstrates over here with these cone-shaped features. This new design would, one, leave a smooth finish on the outside wall. It creates an already threaded hole for the screws, so we don't need any extra hardware. And an awesome thing is that it can print without any extra supports because of the angle of the cone. So basically the cone is an overhang, but it's at such an angle that it can be printed because each layer will be supported by the one below it. So it'll be printed in a supported manner like that. So you don't need to add extra support if your angle is not too steep. Whereas if you had to print like a spacer replacement, exactly how a spacer looks like this, then as soon as the nozzle comes to the end, this end would just droop down. So you would need to add extra support onto that if you wanted to print something at this sort of angle. But since the cone is at a maybe, I think it's about a 45-degree angle, it is able to be printed like that. I'm sure we can all agree that we would prefer not to use supports if possible because they mess up the surface finish, and if they fall over, then our print is likely to fail. So that's why it's cool to use these sort of techniques like this to integrate your support into your design. Linton's next piece of advice was to try to minimize the amount of sharp edges as much as possible. So as you can see on my original design, all of my cutouts still have sharp edges. The top and the bottom also have sharp edges. I did apply some fillets on the corners, but that's about it. Everywhere else still has these sharp edges. All the holes as well. Now, when we look at the drawing that Linton sent, everything has chamfers and fillets. So all of these edges have little fillets. All of the holes have fillets. Every hole, every line on here has been curved in some way. And the reason we do this is to minimize jerk. So most 3D printers have a movement resolution of about 0.05 millimeters. So even a 0.25 millimeter fillet should have a significant reducing in the jerk forces. For your info, jerk is the integral of acceleration. So that means it is the rate of change of acceleration. So minimizing jerk gives a smoother transition and less surface imperfections in your final print. And actually all CNC type machines use this to optimize direction changes. The next piece of advice is to try and minimize the amount of unnecessary small gaps. So if we take this corner pillar, for example, it only touches on the two sides over here. We have this gap over here, which is completely unnecessary. It doesn't actually have to be there. And actually these gaps on the sides here. So this may cause problems when it comes to print time, but Linton showed me a nice way to improve this whole mounting pillar. And you can see he's actually filled in all the gaps. So we've kept the circle and then just filled in and extruded all around the sides here, keeping curves, no sharp edges, remember. And you can see that it actually looks a lot more sturdy. And especially when it comes to actually printing, this shape looks like it will print much easier than if we had just this round pillar that might go wrong, something might misalign, looks like it might go wrong with with printing this, as opposed to printing this sort of shape, which is attached to both of these walls as well. And finally, the last piece of advice that Linton gave me for my drawing was to add this chamfer all along the bottom edges of the box. And the aim of this feature is to reduce the risk of elephant's foot occurring when it's being printed. For those of you who don't know what elephant's foot is, very quickly in a nutshell, it's basically when your first layer of your print kind of gets squished out a bit, so it looks a bit wider than it should be, and it sticks out the edges. So the aim with this chamfer is that we print this first layer here, and then as the layers above are printed and the weight of the object pushes down on this first layer, it will then fill the space of the chamfer. So then it should line up perfectly with the layers above. Ingenious! Worst case, if your printer settings are good enough that it doesn't cause a elephant's foot, the worst case you'll have is a little chamfer on the bottom, but it's really small and hardly noticeable at all. And there you have it. Those are the super useful and valuable tips from Linton at Richie 3D. And I will definitely be using these techniques in my future designs because they make complete sense and is more optimized for the perfect 3D print. And as proof is in the pudding, the final design actually printed out perfectly. I don't think there was anything wrong. My holes were M2, so maybe a little small. But yeah, it came out flawlessly and no elephant's foot. I highly encourage you all to go check out Richie 3D on Instagram and his website. He will be coming out with more awesome 3D printing tips and tricks in the future. If you have any additional tips or tricks for starter 3D printing enthusiasts or people wanting to start drawing their own models, then please leave them in the comments below. I'm sure it'll help loads of people, including myself. And I just want to say a really huge thank you to everyone who has subscribed to the channel. We recently hit 1,000 subscribers. It's so exciting, and yeah, really means a lot. Your support really means a lot. So if you haven't already, you can join us on Discord where we chat about all sorts of different topics to do with making or gaming or whatever we're interested in. Feel free to come on by and drop us a message. Until next time, bye.